Hi, okay, it's kind of been a while and a lot of work's been done on the software, and so I wanted to just give a lightning quick overview of all the new features that have been added in the last month or so. Sorry I haven't made a video in a while, but I've been busy working on it. And I'll make some more videos with some more in-depth look at some of these features in the future, but I thought I would just go through them all quickly. So the first thing is just stability. So if you unplug the oscilloscope from USB, or you unplug the external power, or something goes wrong, whatever, an error message will pop up, and it'll quit gracefully, or won't start up at all, and you will not be confused about what's going on. So that's really helpful. Let's see if I can demonstrate one of those. So I'll just kind of unplug the power, and there you go. So there's exception handling, and the GUI pops up neat things. Okay, so I restarted it. So let's see, the first other new feature I want to show you is this low pass filter. So right now we have a squarish wave coming in, and it's about 350 megahertz. So we can put on these low pass filters. There's your standard 20 megahertz filter. That's obviously going to kill it completely. We can put on 200 megahertz. Okay, a little bit's getting through. 400 megahertz. You're just getting kind of the sine wave component, because you just have the 350 megahertz first harmonic, and you've killed all the other harmonics, and you can turn this off. So that's all per channel. If you have two channels going, then you can apply this independently on each channel, or what have you. Okay, so that's the low pass filter. Let's see what else. You've got this new axis on the right, which shows you the current voltage scale for the currently selected channel, and that's in the color of the currently selected channel. So yeah, if you change the gain, then you're going to see that voltage scale change. And if you have two channels on, then you've got this for that channel, and if you click on the other channel, then you'll see that for that channel, and it's independent. So if you go back to the other channel, then it goes back to what the other channel was. Okay, so that's nifty. Let's see, you can drag this vertical trigger line now. I think I actually showed that in the last video, but yeah, you can do that, and it matches up with what's shown over here. Now, because I'm zoomed in, when I move this one, I'm way zoomed in, so I have a large range of data that I can span across, and so yeah, that you could lose where your trigger position actually is. So you can press this trigger position. It's kind of a hidden little button here, and you can press that or this one to reset the trigger position, or the trigger threshold. If you change the trigger threshold and you want to put it back to the center, then you can do that. But yeah, you can move these lines around, and it all syncs up nicely. And yeah, by the way, there's little triangles here that help you see where that trigger line is, and help you drag it a little better. Okay, we also have this persist feature. So to turn this on, what you do is you just change the persist time, and what you'll see it doing is adding extra lines here that will kind of fade out over time. So if you hover over, it says the persistence time is 1.6 seconds, so it's drawing up to 16 extra lines, and they'll kind of disappear. If you pause, they'll disappear after 1.6 seconds. And then we're also drawing this average line, which is in white. That's the average of those 16 lines. You can either take that on or off. So it just kind of helps you see a little bit more of what the waves been doing when you, something is happening to the signal. It's kind of trippy. And you can turn those average lines off, and you can turn the persist lines off and just show the average if you want to see just that average of the of those 16 lines, and that ends up being way more stable than the individual lines. Okay, so turn that off. You just go back down to 0. That's all per channel also, so you can have it independently for either or both of the channels. Okay, another new feature is reference waveforms. So we have this reference menu now, and we can take a reference, and it's there. Like if you move down this channel, you can see where the old one was. And if you go faster and slower, it scales correctly. You can also save those references to file if you want to, and you can load them back from file, obviously. This is all per channel, so if you have other channels, you can have references for separate channels. You can clear them all, or you can just not show some of them, or whatever. Okay. There's also been big improvements in the FFT. So if we pop up the FFT window here, we can see our square wavy signal, and we can go to log scale, and you see that the positions of all the peaks are labeled with their frequencies, and yeah, you can reset the peaks. If you're changing something, you can reset. You can also add other channels to the same FFT plot all at once and compare them and see them together. And yeah, you can zoom this in if you want. You can move it around. That's nice. I'm just doing that with the middle mouse button, or you can drag with the right mouse button to do that. And yeah, these are Wi-Fi interference, I think, which is, you can see it on the FFT. Occasionally those pop in. I've got my phone not too far away, and it's not 100% perfectly shielded. Yeah, we also have this new measurement box, measurement table. So to add measurements now, you can add all the measurements you want. You can look at the frequency and VPP. And for each measurement, you can remove each of them individually. And also when you click on a measurement, you see this neat histogram pops up, which shows you the current distribution of where those measurements fell. So for the last 100 measurements. And you also see over here the average of those 100 measurements and the RMS. So yeah, that's kind of nifty. Yeah, you can add all the measurements for this channel and see them all at once. We've got rise time, and you can also, if you just want to clear all the measurements, or you can clear all of them for this particular channel, you can do that, or clear all the measurements. So yeah, that's how the measurements work now. Okay, we also have an XY mode now. So if we're over here and we want to look at, let's say, channel 1 versus channel 0, so we can just open up our view and we get XY plot, and we have this new window that we can see things in. So we can select what we want on each of the channels, and the color is matches the color of the channel that we're showing, and then the line is always drawn in kind of oscilloscopy green, and yeah, so that's how you can do XY mode now. Another new feature is settings. So you can now save and load all your settings. So let's say you have this all set up and you have the gain just right, that's probably too big, and the offset, and maybe you have some like cursors set up, but we haven't gotten to those yet, but we have cursors, and they're all set up measuring something the way you want. Maybe you have a low pass filter on there doing something. Maybe you have another channel on there. Whatever, you have it all set up the way you want. Now you go over to File, and you can do Save Setup, and then we can save that, as like test, and it saves it to a JSON file. And now that file's on your computer, you can do whatever you want. You can change whatever settings you like and mess it up however you want. And then it should all go back when you load up the settings again. Like even if you move the cursors around, do something bad, maybe I'll even turn the cursors off. And then I load the setup. There we go. So it's all back the way we wanted. Looks like the persist did something a little weird, but okay. It's basically back the way we wanted it. Okay, there's now also a cursor system. So with cursors, they let you measure things on the screen. So we can pop on our cursors, and we can move one cursor here, and then it'll tell us where the cursor is in time. So this one's at 617.38 nanoseconds, and the other one is over here, and that one is at 659. So we could measure, like, let's say you want to measure the width of this pulse right here. So boom, that's pretty close. And it'll say that the delta t is 5.11 nanoseconds. It'll also tell you what the frequency of that was, if that was one complete cycle. So that makes sense. I think this is a, what is this? It's a 100 megahertz squarish wave we're putting in at the moment. Okay, so, and it'll also tell you the voltage, so you have voltage cursors, and those will change. So that's voltage 2, and voltage 1 is the one on the bottom here. You have a couple options. You can say the time relative to the trigger point, which is here. So now, your cursors, when they move, they don't change relative to the trigger. So this is minus 20.12 before the trigger, and this is minus 15.01 before the trigger. So that's just kind of handy in some cases. You can also do snap to active waveform. If you do that, then when you move this one, when you move the time one, the voltage one will always stay as close as possible to the active waveform, meaning whatever channel you have selected at the moment. And same for the other one. So that'll help you measure it a little more precisely. Like it'll snap right on there, and I could do the same thing for that other one, and then that'll help me measure that that time difference a little bit more accurately. Another handy feature is this peak detection. So peak detection will just show you like the min and the max of your waveform that it's ever seen, at least since you've changed the time base or the depth or some other thing like that. So you can see your wave is oscillating around inside of this envelope. It's graphed as a dashed line, and the other line is being drawn inside of it. And if it went outside, then that would be the new peak, because it would be the new min or max. So that just helps you see kind of what's going on a little bit better with your waveform. Sometimes you have like a weird glitch or something, and that glitch will pop out either really high or really low when something happens in your waveform, and then you can just kind of see it. This one's kind of handy. You can now give your waveforms names. So if you type up here a channel name, like maybe this is the square wave, then it will actually pop up here in this little legend. And if you have two channels going on, and you click on the other one, and you can give that a name too, like this one is the slow wave. Okay, then that will pop up there, and it'll stay there no matter how much you change the gain or whatever you do. So that's kind of useful. If you have a lot of channels, then you may forget which color is which, and that'll be saved when you do like a take screenshot. It'll also be saved to the settings and things like that, so you can remember what your channels are supposed to represent. This is kind of a minor one, but nice feature is you can now add a time skew to your waveforms. So let's say you for some reason want to shift this over in some direction, maybe because you want to line that up with some other signal which is also being plotted synchronously. So you can now just do that, up to 100 picosecond resolution. You can just kind of move your wave around, or you can zero it back. You may notice that the lines have gotten thicker on the plot. So now the default line width is 2. It is a little slower to draw the thicker lines. Like we're getting, maybe 45 hertz now, and if we just draw a thinner line, we're getting more like 85 hertz. So it does slow things down a little, but it often looks a lot better, and it's still fast enough to just draw the thicker line. Another nice thing is that the colors are improved. So with the two channels, you get this red and cyan going on. Instead of like the blue is kind of hard to see. So there's better colors, and you can also change the colors. So you can either just go up here to view, change line color, and pick whatever color you want for it. Everything stays in sync with the axis and everything. Or you can just click the color box up here and change it to whatever you want as well. So another really big feature that could be useful to some people, though really it's more of kind of a testing thing, but you can now have these dummy servers, which are like virtual Haasoscopes, which will create data which you can then show in the program. So let's just start one up. You just go to the Haasoscope Pro software dummy scope directory, and you do python dummy server.py, and you can give it a port number on which to start listening on. So you can start that one. It'll open up port 9998. It makes some like pretend firmware version for itself that then later gets read in by the Haasoscope software. And if we go over to the another terminal, we can start up Haasoscope Pro Qt. It now takes some command line arguments. You can give it a max devices. So if you make that 1, then even if you have 10 Haasoscopes connected, I actually do have 4 connected right now. So I can tell it to only connect to 1. That's 1 real Haasoscope. And then in addition to that, you can have it connect to the dummy Haasoscopes. So with this socket command. So we'll just start that up. Okay, so it should say searching for Haasoscopes connected to some dummies. Let's just see if we can see what that says again. Yeah. So what does it says? It says found 5 devices. Those are my 4 plus probably a USB blaster or something. It only opened 1 real Haasoscope board. That's this one here. And then it's going to try to connect to localhost 9998. it connected to it just fine, and yeah, connected to this dummy one via a socket. And then all the other normal stuff. So from then on, it's really just acting pretty much like a normal Haasoscope, and it's making some dummy data. So you can see it's making this this yellow line here. So that's board 1, and if it's a dummy one, it has a little D next to it, just so you don't think it was like actual real data. Right now it's like triggering on other boards. We can say trigger on a falling signal, and then it's nice and clean. I might need to increase my delta, since there is noise being simulated on the signal. So if we zoom in, we can see all this noise. So there is some white noise just being generated to make it a little more realistic. Actually, it looks like there's more noise on that than there is from a real Haasoscope, but okay. And yeah, everything else works. You can change the gain, you can change the offset, however you like, and it'll tell that dummy server to, you know, generate fake data, which is going to pretend to be that kind of wave with that gain and offset. And then you can analyze it in this software just like you normally would. FFTs, math functions, references, all that will of course work the same as with real Haasoscope data. You can also pull up in the advanced menu. If you have a dummy scope connected, this will be enabled, and you can do the dummy scope menu here. And when you pull that up, it'll let you adjust configuration of the dummy scope. So for each of the 2 channels, and yeah, it'll work fine in 2-channel mode, by the way. So I can pop up the other channel. So right now on channel 1, we have pulses, it looks like. So we can change the parameters of those pulses. Maybe first we should trigger on those pulses. So let's trigger on the rising edge of channel 1, and we will maybe turn off that channel so that we can see it better, and maybe we'll get rid of this real Haasoscope data too while we're at it. Okay, so now we can adjust the parameters of those pulses. Maybe we need to trigger on them a little bit better. And what can we set here? We can set the frequency, so like how often is there a pulse. We can set the amplitude minimum and the amplitude maximum. So they'll be as small as 10 counts now and as big as 500 counts. We can make that say 1500, and we'll get bigger pulses. So they're randomly distributed pulses, and this is, you know, we can now make fake signals that we want to be able to test our triggering on and our software on. Okay, so that looks good. You can actually also change and make a square wave. There's a square wave. I have over this upsampling on, so it doesn't look so square, but if I turn that off, it looks more square. And you can change the parameters of the square wave, like make it a sharper square wave, or you can make it a much less sharp square wave. And that's just a parameter of the square wave, like the rise fall time of the square wave. Oops, I probably want that to be back at like there. Yeah. You have to click enter to update at the moment. Okay. So yeah, that's nice for testing things. If we go back to our pulses real quick, I want to show another new thing, which is somebody recommended that that it's nice for these pulses to trigger on them not at a specific trigger point. Like right now, we're always triggering at this point right here, which is delta above the trigger threshold line, or now it's 0 above the threshold line. It's always gonna kind of start there, whereas if you do the pulse stabilizer, now it triggers at halfway between the min and the max, which just adds some more stability for that pulse. Kind of the peak of the pulse is always going to be at the same place now, as opposed to here. It's going to bounce around a little bit more. We also have this new history feature. So what you can do here is it's always actually recording the events to this history buffer, and if you go to view history window, you can pop up this history window, which will pause the acquisition and it'll show you the last 100 events, and it has the timestamp of each one, and you can go back and you can cycle through and see the last events. So if you then start taking some new events, maybe you change the gain, maybe you're going faster, you're selecting some new things, maybe some new channels, those will all get recorded in here, and you can see those are the new events, and you have the older events in here. The time is not, you have to actually show the go back to change the zoom so that you're looking at the same time scale if you want to. That's independent, but the event data will be there for the old events or the new events. And you can save this to a file, so test, and that will save it, and then you can come back later, and even if you've been running for a long time and you change some things and you're have a totally different signal, you can come back and open up that history again and go to these are all going to be the new events right now, but you can load the history and you should see the timestamp. Go back in time, to a couple minutes ago already, and that's all the events that we were looking at before. I also really like this new zoom window feature. So if we go to view zoom window, we open up a new plot here. It's a new window, and it's a zoomed in version of the original here. So we can move that around, and you see there's a region of interest that we can put over whatever we're interested in, and we can see that exact region of interest zoomed in the new window, and everything shows up there. The trigger lines are there. It's exactly like the original screen, but it's just a zoomed in copy of it in a new window, and you can adjust with this little region of interest. So I think that's neat. So we also now have math channels. The way these are going to work is you just go up here, you open the math channels window, and the idea of a math channel is that you can add like virtual channels which are going to use the data of actual channels, or reference data or other math channels, actually, as we'll see, in order to create these new virtual channels. And you can have up to 2 channels as an input to each of the math channels. So here we have board 0 channel 0, and we could choose like a single channel function. Like let's just say we want to invert that function, invert that signal. So now we add the math channel, and we have a new channel, which is a math channel, which is going to be the inverse of that. Now what can you do with that? You can take a reference waveform, so let's try that. Oh, I have to take it and then I can show it. So now even if we don't display it, you can see the reference math waveform there. We can not display that reference waveform. Here's another thing, so you can use it for the measurement menu. So now if we go to measurements, we could say measure the duty cycle of that inverted waveform. Okay, that's nice. Let's get back our menu. You can remove the channels, remove all of them. You can change the color. If we don't like that color, it should change. And yeah, also changes in the measurements. That's nice. And you can use it for the FFT. So we can take an FFT of it and it'll get added to our FFT window. I had some old stuff in there from before. Yeah, then you can also, for instance, use that new math channel as an input to other math channels. So now that we made that math channel, we can use math 1 as an input to another math channel. And let's say we wanted to multiply that by board 0, channel 0. So we've got the inverse and we're going to multiply it by itself. And okay, let's add that, and okay, that's what it is. And then you can, use that as inputs for other things. So you can keep building up things, which is kind of nice. If we had a reference of something, so if we take a reference of that original red signal, so it's there now, and if we wanted to, we could use that reference as an input also to the math functions. So you can get quite fancy here and build up some complicated things. Of course, then you can go to File, Save Setup, and all these will be persisted to files, so they'll come back when you load them back in later. And yeah, just to make things even fancier, you can define custom math operations. So let's remove those. We can define any new operation we want. So we can use A for channel A, B for channel B. So for instance, if we want to take the average of A and B, we can just say A plus B over 2. And you can use any kind of NumPy function even to do this, and it will work. Yeah, you have to, that's the operation name, and then the expression goes down here in that box. So we could call this like average. Okay. And now we have down here custom operations, and we have average. So we could use that. You can also remove the custom operation if you wanted to. If you have one selected, then you can remove that custom operation. So yeah, so now we need, let's say we take the average of that reference and board 0, channel 0. And we can add that math channel, and there it is. It's the average in between the two. And then you can use that for, all these other things that we did before.